Network innovation is the key to how communications providers will transform their services with greater performance and flexibility and at a lower cost. Here in Belgium, Intel is playing a key role in this transformation, working alongside telcos and indeed the entire ecosystem to develop new standards and open methodologies.
Intel has our own labs. We have over 6,000 scientists and researchers around the world working on everything from devices to data center clouds to networks. Our mission is to create and extend computing technology to enrich and connect people. Now we've taken the PC technology and moved that into the cloud, in the data center, but we haven't really taken that kind of capability into the network yet. The network is physically different from a data center. It's got a global topology, so there's huge distances involved, and the speed of processing the packets, the internet packets across that network is critical.
Here in our lab in Kontich, we're looking under the hood of these systems on how they can perform fast packet processing. Handling many millions of packets per second to go through that network is the key of what a telecoms infrastructure is supposed to do.
The telcos or the communications companies are coming to us and saying, look, we don't want to be just a dumb pipe, which is the way they are perceived and to a certain extent the way in which they are used at the moment. They want to add value, and there's compute, storage and connectivity. They're all working within this massive global network. They want to unleash that capability and take the value that can deliver and provide that to their customers.
We work with service providers almost on a weekly, daily basis to really find out, okay, how many customers do you want to serve with this particular system? What is the exact load? What is the shape of the traffic? So that we are really answering their questions and not just some theoretical research. We're having here behind me quite some racks with machines with the latest Intel computers, of course also with our future machines that are not yet commercially available, but so that we already can predict what these new features will do to our performance.
As the CPU capability has improved, Moore's law driving more density and higher speed, more performance, we're now reaching the area where the data plane speeds can be managed on a standard high volume server platform. So the kind of things that we've done in the enterprise around virtualization can now be applied in the network environment. So that's a fundamentally different approach to processing these packets within the network from the more proprietary historical way of doing it.
The data plane is key. The data plane is then the actual content, so the film, the voice, the media that is transported through that network.
We have something called the Data Plane Development Kit, DPDK. That is enabling us to manipulate these packets right down at the data plane layer where this high-speed requirement is absolutely crucial. That's widely being accepted within the industry and the ecosystem as a way, as a tool to develop these new solutions.
So the key in here is doing this at very high speeds, but also on standard computers. That is the main thing. We want to lower the cost, the total cost of ownership. We want to increase the flexibility because there are many people out there that can program standard software, standard hardware.
So what we've learned working with our ecosystem partners in this open standardized environment is that we need to provide tools. We learn how to manage the technology. It's no good us trying to make that proprietary and keep it to ourselves. The best thing that we can do is to actually get it out to the ecosystem.
We do the hard work by writing prototype demonstrators. We write papers that are explaining which design decisions we took and why. And in the end, that results in performance data. First of all, we put this available on the internet so people can go there, download it. But secondly, we also directly work with our main customers. For example, telecommunication equipment manufacturers like NEC and others. We can then go to them and have technical discussions on the right level.
The comms companies talk about 5 nines reliability, quality of service. We believe that these are absolutely crucial in the network, and our ability to operate right down at the packet level and to manage these packets and know exactly what you're doing with these packets so that you can send them where they need to go, when they need to go there, make sure they're secure. These are all critical issues that we're examining in labs like the labs here in Belgium. If you can't manage this traffic flow in the network, then you're going to continue to have unhappy customers and dangerous situations. So this is a crucial area for research and development, and the labs environment is where it starts.
This is Guy Daniels for TelecomTV in Kontich, Belgium.